Okay, pre-calc. Today we're going to do more with vectors, and we're going to talk about dot products. So if you recall, when we add two vectors together or when we subtract two vectors, our answer is another vector. But dot product of two vectors is another vector operation, but the answer is a scalar or a number. Your answer is just going to be the number. So suppose we have two vectors, v is a1, b1, w is a2, b2. The dot product, v dot w, equals a1 times a2 plus b1 times b2. Those are just going to be numbers. The answer is going to be a number. So let's look at a couple examples here. Number one, we've got P is 5, -2, and Q is 1, -9. The dot product, P dot Q, is 5 times 1 plus -2 times -9, or 5 plus 18, which equals 23. That's your answer. Okay, number two, we've got R and S, and R, I won't write them down since you have them in front of you. R dot S is 0 times -2 plus 4 times -4, which equals -16. Number three, V dot W is, now these vectors aren't written in component form, they're written as a linear combination of I and J. So it's going to be 7 times -1 plus 8 times -9, which is -7 minus 72, -79. And number four, we've got C dot D equals 3 times -2 plus -7 times -2. So we got -6 plus 14, and that equals 8. Okay, that's how you find dot product. Pretty straightforward. Two vectors are perpendicular, then their dot product is equal to 0. If they are perpendicular, the dot product is equal to 0, and vectors with a dot product of 0 are also called orthogonal. It's just another word for perpendicular. So let's determine whether the two vectors here are orthogonal. We're going to find the dot product and see if it equals 0. So for number 5, we're going to do m dot n, which is 3 times -28 plus 7 times 12. And we get a -84 plus 84 equals 0. Yes, those two vectors are orthogonal. Number 6, G dot H, we have -3 times 40 plus -2 times -15. This is -120 plus 30, which equals -90. No, these are not orthogonal. Number 7, X dot Y, is -5 times -1 plus -1 times -5, which equals 5 plus 5, which equals 10. No, they are not orthogonal. And number 8, U dot V, is 12 times 9 minus 18 times 6, and that is 108 minus 108, which is 0. So yes, they are orthogonal. Okay, here's some properties of dot products. Okay, properties of dot products. U dot, or V dot W equals W dot V. Doesn't matter which order you go, you're going to get the same thing. Okay. V times W plus X equals V dot W plus V dot W. Okay. And just a minute, I gotta look at that one for a minute. That's kind of weird. This is like V dot W plus X. So you can add W plus X and then take the dot product with V, or you can do the dot product of W and the dot product of X. That's what that is. X, V, W, and X are all vectors here. K is just a number. K is a real number. So if we have K times the dot product, that's the same thing as K times V times the dot product of W, or V times the dot product of K times W. Okay, K is just a number. And 0, the dot product of 0 and V is 0. And the dot product of a vector with itself is its magnitude squared. Okay, that's the one that we're going to use most often. So if, going to the next page, if this is true, if the dot product of a vector with itself equals its magnitude squared, then its magnitude equals the square root of its dot product. Okay, we're just going to change that around. So you can use the dot product to find the magnitude of each vector. I think this is kind of silly because let's just look at an example. Number 9, R equals 10, 24. If you were going to find, so this says use the dot product to find the magnitude. If you were going to find the magnitude of this, you would have said that is the square root of 10 squared plus 24 squared, right? That's how we found magnitude before. Now they want you to use the dot product. They want you to use this. So we're going to say the magnitude equals the square root of R, the dot product of R with itself. So if we look at it like this, that's going to be 10 times 10 plus 24 times 24. Look, it's the same formula. So I don't know why they just want you to see that the dot product and the actual magnitude, not that. This is the same formula. So the actual magnitude formula and the dot product formula are the same thing. So in this case, when you do this, you're going to get the square root of 676, which equals 26. Okay, so let's look at number 10. Again, it's basically the same formula. A equals negative square root of 7, negative 13. Finding the magnitude using the dot product, this is going to be negative square root of 7 times negative square root of 7 plus negative 13 times negative 13, and that equals the square root of 176, which is 4 times the square root of 11. That's your answer. Number 11, V equals negative 2I plus 18J. So the magnitude of V is the square root of negative 2 times negative 2 plus 18 times 18, which equals the square root of 328, which is 2 times the square root of 82. And the last one of this, K equals 14I minus 3J. Magnitude of K equals the square root of 14 times 14 plus negative 3 times negative 3 equals square root of 205, which I don't think anything goes into that. I think that is simplified like that. So that's how you find the magnitude using the dot product. To me, it's basically the same formula. So it's just finding, basically just finding magnitude. Now we're going to find the angle between two vectors. Okay, using the dot product. So we're going to say if theta is the angle between non-zero vectors v and w, so there's a picture right there. Here is v, here is w. We're looking for this angle right here. Okay, the formula for that is cosine of theta equals the dot product of v times v and w divided by the magnitude of v times the magnitude of w. That's what we're going to use to find this. If the angle between the vectors is 90 degrees, then the vectors are perpendicular, obviously. If the angle between the vectors is 0 degrees or 180 degrees, then the vectors are parallel. Okay, so let's look at some examples. Number 13, we've got two vectors, 8, -7, and -7, -3. So, well, let's see. Let's draw these vectors just so that we can see what they look like. Okay, 8, -7. Okay, there's u, and then -7, -3. There's v. So this is what we're looking for right here. We're looking for that angle between them. So in order to do that, we need their dot product and we need to find the magnitude of each. So let's start by finding the dot product. That's going to be 8 times -7 plus -7 times -3. And that equals -56 plus 21, which equals -35. And then we need each one's magnitude. So we'll find the magnitude of u. And that's going to be the square root of 113. And we're going to find the magnitude of v. And that's going to be the square root of 58. Oh, I did that wrong. This isn't, this would be 3 squared. Okay, so 49 plus 9. And then we're going to say cosine of theta equals -35 over the square root of 113 times the square root of 58. You're just going to be putting this in your calculator, so you don't need to simplify these square roots at this point, because you're just going to be putting it in your calculator. Since you're looking for an angle, you're going to take the inverse cosine of -35 divided by the square root of 113 times the, make sure you put your, parentheses if you need them. So -35 divided by square root of 113 times 58. And you get 115.62. Theta equals 115.62 degrees. And that is the angle between those two vectors. So let's look at another example. Number 14. We've got m equals 0, 6, and n equals -3, 5. If we want to just look at them over here. We got 0, 6, so there's M, and we got -3, 5. So it looks like this. So there's going to be your angle right there. Your angle, it's kind of nice to draw a picture sometimes so you can see if what your angle you get makes sense. Like, look at this angle. It's small. If you get a huge angle, then you must have done something wrong. So let's find what we need. We need the dot product, which is, whoops, not that, which is 0 times -3 plus 6 times 5, which is 30. And then we need the magnitude of both of them. Magnitude of this is 0 plus 36, which is 6. And the magnitude of n is the square root of 9 plus 25. The square root of 34. Okay, so wait. Am I doing this wrong? No. So to find our angle, we're going to say cosine theta is 30 over 6 times the square root of 34. We're going to put that in your calculator. And you get inverse cosine of 30 divided by 6 times the square root of 34. Inverse cosine of 30 divided by 6 times the square root of 34. And you get 30.96 for theta. And that's your answer for your angle. And it makes sense. That looks about right. Okay, let's do the last two. Number 15. We've got, oh, that's A. I thought that was a U. We've got A equals 6I plus 7J, and B equals 9I minus 6J. So if we go ahead and graph these so we can see what makes sense. Okay, if we graph them, we go 1, 2, 3, 4, 5, 6, 7. So there's A, and we would go 9, -6, and there's B. So that's the kind of angle that we're looking for right there. So let's find what we need. The dot product is going to be 12. It's going to be 9 times 6 plus 7 times -6. And then the magnitude of A is the square root of 36 plus 49. And square root of 85, and the magnitude of B is 81 plus 36. So cosine theta is 12 over the square root of 85 times the square root of 117. Now look, you can put those together since they're multiplying. If that's easier to put in your calculator. And you could even simplify it more if you wanted. Inverse cosine, 12 divided by the square root of 9945. And you get theta equals 83.09 degrees. And we got one more. I'll just do it. Number 16. We have P equals I plus 2J, and Q equals -3I minus 6J. So let's see what we need to do. P dot Q equals -15. 1 times -3 plus 2 times -6. That's -3 plus -12 equals -15. And then we find the magnitude of P, which is 1 plus 4, square root of 5, and magnitude of Q, which is 9 plus 36, square root of, 45. And if we put those together, 45 times 5, 45 times 5 is 225. So we can say cosine theta equals -15 over the square root of 225. Go ahead and put that in your calculator. Actually, before we do that, we didn't graph these. Let's see what they look like. 1, whoops, I didn't do those. 1, 2, and -3, -6. Ooh, look at those. What do you think your angle is going to be? If you do inverse cosine of -15 divided by the square root of 225, you are going to get 180 degrees. Because look, those vectors are just opposite of each other. And the square root of 225 is 15. So this is the same thing as cosine theta equals -1. And where does cosine theta equal -1 on your unit circle? At pi, or 180 degrees. Okay, that's the end of dot products. Pretty straightforward.